Hey, good morning, everybody. In this video, I was just going to go over a couple examples from the 6.6 worksheet so you guys have, you can see what the expectations are for this homework assignment. So the first couple, well, we're really only going to introduce two new ideas, and that's max, min, relative max, relative min. And when we talk about maximum or minimum, we're really talking about the highest point on the entire graph or the lowest point on the entire graph. Whereas when we're talking about relative max and relative min, we're talking about a point that's higher than the other points around it. And same thing with relative minimum. It's a point that's lower than the other points around it, but there are potentially other points on the graph that are lower than it. The rest of it's going to be similar to the things we've done, increasing, decreasing in behavior. So in the first example we have here, we're just given an equation. We are not given any type of graph with it. So what we actually have to do in that situation is graph the function in order to see where these different points happen. Whoops. So to do that, because we don't have graphing calculators, we're going to go ahead and use Desmos. So I'm going to pull that up on my screen and I'm going to graph this first function. So what we have is we have y equals 5x cubed. We got to make sure we get out of the exponent. It's minus 2x squared minus 10x plus 1. All right, so you look at this and here's our graph. All right, and this is really the graph that we're going to use to answer these questions. So one thing that's nice about Desmos is the key points, you can really locate them by just touching the graph and identifying where they are. So if you touch where the graph crosses the x-axis, that's going to give us our x-intercepts that we want to use. So we've got an x-intercept at negative 1.282. So let me write that down. So we got negative 1.282. We had another x-intercept at 0.099. So 0.099. And we had another x-intercept at 1.583. And notice I just wrote the x values because that's the x value where it's crossing the x-axis. All right, so then when we look at the graph, the next piece that we're looking for is those relative mins and maxes. All right, this graph, because it goes down forever and it goes up forever, there is not going to be a true max or a true min because it goes down forever and it goes up forever. So we're only going to end up with relative max and relative mins. This point right here, which we would consider, a point higher than all the other points around it, would be what's called our relative max. Sometimes it's also referred to as a local max because it's higher than all the points around it, but there are points over here that are higher than it. So we're going to go ahead and just write the coordinate for that. So it's negative 0.694, 5.305. So our relative max is at the coordinate negative 0.694, and I think it was 5.305. Now, technically, the maximum is just the y value. So really, if you were just going to use one value to identify that relative maximum, it would be the y value because we're referring to the height of the function. And then if you look at the graph again, you have this point down here, which is lower than all the other points around it, although there are some points over here that would be lower than it, all right? But this would be considered our relative minimum. So that's going to be at 0.961. Let me just go ahead and write that. So 0.961. And then the y value was negative 6.02. Again, if you were only using one value to identify it, it would be this right here. Now, because this graph went down forever and up forever, there is no true max. So the maximum would be none or does not exist, and the minimum would be none or does not exist. Because the graph goes forever. There's not a highest point and a lowest point. All right, if we were going to try to sketch this graph, just so we have something to look at to answer the rest of these questions, I'm going to do my best to just approximate where these points are. So we had x-intercepts at negative 1.282. That's going to be somewhere in this area. We have another one at 0.099. That's going to be, somewhere around here. And then 1.583, a little bit more than halfway there. All right. We had a maximum at negative 0.694, 5.305. So when I go over left, a little more than a half. I'm going to go up 1, 2, 3, 4, 5, a little bit more than 5. And then we had this minimum, relative minimum, at 0.961, so almost 1, and then down a little more than 6. So 1, 2, 3, 4, 5, 6, just a little bit more. So I'm just sketching the graph based on what the calculator showed us. And what's going to happen is the graph's going to go down, right? It comes down through here, touches down here, and then it turns back up around. Now, from there, once you have the graph, we can answer the end behavior part of this, right? So as x is approaching infinity, that's the right side of the graph, our graph is going up to infinity. As x is approaching negative infinity, meaning the left side of the graph, well, the left side of the graph this time is going down, so that's negative infinity. And then when you start talking about increasing and decreasing, the points that actually become extremely important for increasing and decreasing are those relative mins and maxes. So this point was at negative 0.694, 5.305, and this point down here was at 0.961, negative 6.02. And I say that they're important because those mins and maxes are where your graph is going to go from increasing to decreasing or decreasing to increasing. So starting over here on the left side of the graph, from negative infinity, as we move to the right, our graph is going up from left to right. So it's increasing from negative infinity, until we get to that relative maximum of negative 0.694. At negative 0.694, it then begins to decrease until we get to that relative minimum of 0.961. And then at that relative minimum, 0.961, it increases forever to infinity. And that's how you would answer those questions. If one way to think about these relative mins and relative maxes, all right, a relative max, which is what we have right here, relative max is going to look like a mountaintop. This point down here, which is a relative min is going to look like a valley. So mountaintops are relative maxes, valleys are relative minimums. Now, if that point happens to be the lowest point or the highest point on the entire graph, then you would also identify it as a true max or true min. It's like being the richest person in Reno versus the richest person in the world. The richest person in Reno is not the richest person in the world, okay? But relative to where they live or locally, they would be the richest person. And that's kind of how we think about these points. This point is the highest point where it is, but there are other points over here that are higher. All right, guys, I hope that helps with this assignment, and I will hopefully see you next class.